In this video, we're covering the chain rule for differentiation. So we use this when we're trying to differentiate composite functions, where we have some sort of one in a bracket to the power of something else. So the formula is dy over dx equals du over dy, dy over du, times du over dx. So I'm going to explain what this means in an example. So I'm going to do it. There's two methods to do this. I'm going to show you the long way, the traditional way, and then I'm going to show you a kind of shortcut way. So the first way to do it, the long way, is here we have our function. So we're going to write dy equals 8x cubed minus 1 to the power of 5. So what we do here is we actually let u equal my 8x cubed minus 1. So what I end up with is two equations. We end up with y equals u to the power of 5, and over here we end up with u equals 8x cubed minus 1. We can now differentiate these. Now, this is where the dy over du comes in and the du over dx. Whatever your first term is, so this y, right, that's what's on top. So that's why this one's going to be dy. And then whatever's in the second over the other side in terms of is your du, or the bottom one. So this ends up with 5u to the power of 4. And over here we end up with du because that was our subject, over dx because that was our terms. So we end up with 24x squared over this side. So this fits in with the formula we just had. Remember that the formula was dy over dx equals dy over du times du over dx. And we have all that we need now. So we can substitute these in. So you end up with 5u to the power of 4 times 24x squared. And now we can combine these, essentially. So what we end up with down here is we end up with 120x squared and then u to the power of 4. But remember that u equaled 8x cubed minus 1. We don't want to leave x's and u's. We would ideally like just to be x's. So what we do is we go and substitute that back in. So 120x squared, and then we end up with 8x cubed minus 1 to the power of 4. We've replaced the u with what we set it as. Now that is what I would say is the long way. So I'm going to rewrite it down here, and we're going to do a shorter way, I believe. So remember that y equaled 8x cubed minus 1 to the power of 5. So what we're going to do is when we differentiate this 5 is still going to come out the front, but then we're going to times it by the differentiation of what's in the brackets. So what I mean by that is, what we're going to have is 5 comes out the front, so y equals 5. We're going to differentiate what's in the brackets, so that equals our 24x squared. So we're going to times that by 24x squared, and then we rewrite the bracketed areas with one less power. All right. So I don't know if that seemed easier, but the trick here is, again, you do the same thing as if you were doing it traditionally. The 5 comes out the front, you minus 1 off to get 4, but then you just need to remember you need to multiply it by the differentiation of what's in the brackets, okay? So what we kind of end up with is your power times the differentiation of your brackets. Then you have your original term, and then your new power up here. So what we end up with is 120x squared 8x cubed minus 1 to the power of 4. So those are the two ways. So this is a more traditional way, which I definitely recommend practicing. But then if you get to the shortcut way, to save some time, you've got it here and in this example.